This is my SolidWorks model of my project. When I came up with the idea at first, I wanted these pieces around the outside to be able to move in and out all at the same time, so that when they moved in, they created one solid image, and that was of a light bulb. But I had never seen anything done like this before, and well, I didn't even research it. For them all to come out from the center and move back into the center at the same time, it would require a different kind of mechanism. So this is the effect that I achieved in the end, and it was because of this cam here at the back. And it's a cam that works in two ways. Usually we have cams that work in one way, where they just push out like it is doing here. This one also pulls it back in, so it pushes out with this side here, and then it pulls it back in with this side. Obviously the cam has to be able to rotate in both ways, so I'll have to use a genie board to make the motor rotate clockwise and then anti-clockwise to both push out and pull back in the cam. I made it the very same way as I made it. You can make any other cam. I just simply made out a displacement diagram like this here. The reason I have only 3 sections is because I'm only using 1/4 of the cam. I'm only designing 1/4 of it. All these, each part here is exactly the same, and they all represent 90 degrees of rotation. That's 1/4 of the cam is taken up by each part. So I don't need to do a displacement diagram out for each one. The same measurements are going to apply every 90 degrees. So it just saves time and effort. So what I did was I calculated the amount that I wanted to displace these pieces. So whatever amount I wanted these to come out and then back in. And that's also equal to the distance from the center of this to the center out here. That's the displacement of the cam. How much it can push out the follower, which is these cylindrical pieces here that are attached to my front face pieces. How much it can displace them, push them out, and how much it can bring them back in. That's going to be the height of my displacement diagram, not the distance from the center out here or the center to here. It's going to be the amount that I want to displace it, because that's the part of the cam that I'm designing. I'm not designing in here. So what I want to design is from here out to here. So what I did was I made a displacement diagram. This displacement diagram obviously represents 90 degrees, as I said. And I'm going to use simple harmonic motion, so you have to get your circle divided up into 6. And then you're also going to have to divide whatever amount you want up into 6 as well, to get the points for your spline. Now, so all those are fully defined, which is important. Now I'm going to put a point on each intersection of the lines here. There's already one there, and there's already one almost up there. So I'll just fully define them as well. This is so the spline can have defined points in which to pass through, or else it won't be defined in the end. Okay, so now I draw the spline. It's the same as any other displacement diagram that you might do when you're even on a drawing sheet. It's just that we want to get accurate measurements for our cam. You could even do it on a drawing sheet and then get the measurements. This is just a lot simpler and a lot more accurate. You're sure it's going to be right. Okay, so that's our spline there. That's our displacement diagram. If you were to do it again and again and again, it'd just be the same. So that's why I just concentrate on the one section. Each of these lines, every second line here that I showed at the start, is 30 degrees. So that's 30, 60 and 90, which is 1/4 of the cam that I want to design. Okay, now the next part is going to make the sketch go a bit mad, but I don't want to get any resultant part from it, so it doesn't matter. What I want to get from this is the measurements, at which this here is far away from the point, the inner point. So this line here represents the center of this here, and the top line in my displacement diagram represents this, because that's the maximum diameter, or the maximum radius, and this is the minimum radius. And what I want is the displacement 35, so that's what I did here. I did the maximum radius, take the minimum radius, and that's it there. Okay, so what I want are the measurements from the minimum radius. That's 2.34. As I said, the sketch is going to go a bit mad, but it doesn't matter because I just want to get the actual measurements from these pieces, or from these points that the spline passes through. So if these lines, every second line here represents 30 degrees, 60, then 90, these must represent 15, 45 and 75. So that's what I'm going to make in my next part. I'll just make a part now of how to make the actual cam, given that we've found out the dimensions. Okay, so we'll sketch on our front plane there. We'll sketch 2 circles. Now we'll put a point here and there. I'll make this 35. So that's going to be the displacement diagram basically. Now I want the center of the cam to be, say, diameter 20, just for a bit of strength. So that's fully defined now. So that's diameter 20. Now I want to split up a quarter of my cam into 0 degrees, 15 degrees, 30 degrees, 45 and so on. So I'll just draw these lines here. 30, 45, 60, 75 and then 90. Okay, delete these little ones in between. Okay, now we'll just put the angles on them. So 15, 15, okay, so I already had that. Okay, so there are different points, there are different sectors that we're going to put our points on for this curve that we're going to draw. And how we get our distances to go out on each one of these lines here is back to our displacement diagram. A good way of flicking through tabs in SolidWorks is Control, Shift and Tab. It goes to the previous one that you were just on, so it'll be very, very simple for this when you're trying to get measurements. Alright, so this is 2.34. I'll just put on points here, because I don't want it to be from the center, I want it to be from the minimum radius, because this is 35. So this section in here actually represents our displacement diagram. So I'll put points on each place these intersect. So I'll be able to then dimension away from those points. Okay. Now 2.34 is our first point. So our point here is 2.34. But our first point really is here, sorry. So it's 0. So that's our first point. That's at 0 degrees. So that's 0 height. Our second point is here. And this is at 15 degrees. So that's our second height, and that's 2.34. So I'm just going to draw that point there. Smart to mention it. 2.34. And that's done. Next point is going to be 8.75. So I'll put the point on the line. Might as well put it on all lines as well, just so I can smart to mention it, then is all I need to do. So 8.75 for a second point. Third point is 17.50. 17.50. Fourth and fifth, 26.25 and 32.66. Also very important that the lines, the dimension lines that are coming from the arrow to the line are 90 degrees to that, like as I was doing here. I'll just do it again. I was able to get a dimension here, but that wouldn't be right, it's not the radius. We're calculating how far it is out on the radius line from the diameter or the circumference of this circle here. So that's how you do it. Okay, now all these points are defined. Should be alright. Good to make sure that these are all at the points of intersection as well. So if they just don't go first time, just make it coincident to the radius line, and then you have a fully defined sketch. Now what we need to do is draw our spline. We have all those points defined. All these points have to be defined in order to ensure that you have the correct spline. So we'll have, that's our first point is at 0 degrees and it's 0 height, and then this point, this part is very simple. Okay, now we have a fully defined spline, and that's simple harmonic motion is what we use as well there. So now what I want to do is just draw another circle outside of this, which is going to be the outer, basically the outer circle that's on this here. This will be the edge of it here. So what we've drawn is the center of these. So I want to draw the outer circle now for something to house it in. So something that can be cut out of. Right, so this circle here, say we could make it, yeah, we could make it around 50. So 100 diameter. Okay, now what we need to do is make a slot out of this curve. So what you want to do is offset entities, select that entity, and then create. I'm going to do 3 because that's general size kind of, because it's going to be 3 either side, so that'll be 6 mil. So let's 3 that way. Yeah, and then again offset entities, and then 3 that way. Okay, that's done. Now what I want to do is create something for the follower to finish in, so it's going to have to be a circular profile on either end. There and there. Make it tangential to this. Make this tangential as well. Now we have that fully defined. Now what I want to do is I want to replicate the slot that I've just created. As I said before, like it's 90 degrees, it's going to be the very same as you go around. So what I want to do is I want to, first of all, copy entities. I'm going to copy the outer profile of that slot. Okay. And then start from point right here in the circle. So it's going to be starting every 90 degrees. So all you have to do is have it there, here, and here. Okay. Now what I want to do is I want to rotate entities. So I want to rotate this slot here, which is my first one. I want to rotate that 90 degrees, I think. Center rotation is also used like as well. Sorry. So 90 degrees. We'll try that. Okay. So it's, oh, I see. Okay. So it'll be 270 degrees. So it'll be doing it like any other circle in which we have angles where 0 degrees is here, there's 90 degrees, there's 180, and here's 270. Forgot about that. Okay. Here is our next point that we want to rotate. This is our next slot that we want to rotate. Now this one will be going to 180 degrees. 180. Okay. And you know it's right because this is on, this center here is on this line here. So we know that that's right. Okay, now rotate entities again. Rotate our last slot. Center of rotation again is just going to be at this point here, and we're going to go, this time it'll be 90 degrees, and that's all of them rotated. Okay, now as you can see here, it's not fully defined. They're able to move around, and that's not what we want. So what we want to do is fix their points. Make them fixed. And also sorry, want to create the same as before, make these tangential to here. When you copy and rotate them, don't copy the relations as well. Maybe there's a better way of doing that, but this is how I'm doing it. Okay, make them fixed. Then we make these tangential, same as before. I'm sure there is a better way of doing this, but I haven't found out yet. Gets the right result anyway. Okay, these are the 4 points that I want to make fixed. Again and again, just make tangential. Okay, so what I want as well is this will be my profile here that I'm going to cut out. So I also want to show this will be a slot in the piece. So what you can do is you can extrude it now and select these contours here. And you get this piece. It'll work the very same way as the cam that I've shown here. That's the very same as that cam. It's just that in this cam I've not even saved material, but I've reduced the weight that it's going to take to rotate. Reduce the weight of the cam, so it'll be in some way easier to rotate for the motor, and it'll look nicer as well, a lot more fluid. So if you want to go and do that now, it's okay, but I'm going to go through how to make this profile here now. Okay, now so to create that profile that I was talking about, I want to first of all delete this outer circle, because that was just to extrude the cam as a complete solid object, as a circle with just slots taken out of it. But now what I want to do is have slots taken out of it, but those slots define the outer profile of it. So what I want to do is first of all delete that circle obviously, but then I want to offset those slots, the outer edges of those slots. What I want to do is have an offset of 5mm from here to here. So that means I have to have 8mm from the center here. I don't know why it doesn't offset this. It doesn't offset this 5mm. So I need to have an offset of 8mm from the center out to this line. And I'm going to have to do that on the other side as well. So offset into these. Then the side you want it to go, and that's it there. And offset into these. So since the semicircle is actually on the slot, you're going to have to do that to 5. And that's done. And they all fully define themselves. Now, slot, these are all to 5 now. Offset into these, 5. And then offset into these again, 5. Right, so what we don't need here is these semicircles at the very center of it, because that's not the profile we want. We're not going to be offsetting that and cutting out these as well. We just want the outer edge. So we can delete them and keep obviously the semicircles of the slots themselves. Okay, now what I did to complete the outer profile was just drawing a semicircle. It's tangential to both of these sides, so it's tangential there to this spline, same as before, and it's tangential to this spline as well, and that's fully defined, so it's okay. Offset another semicircle then, tangent to that spline, no, I selected some by accident there. Alright, so the semicircle tangent. Let's stop me from doing that. Okay, don't know what happened there, but it should be able to work alright. Okay, now the semicircle tangent to this curve, and also tangential to this curve, and then the semicircle again, tangential to this curve first, and then tangential to this curve, and that will be fully defined again. So what we need is to just get it fully defined. So tangential again. Okay, now we have our profile, and what I like to do as well is just to draw in the slot, the hole that the shaft is going to be going in through, so that's going to be 6mm in diameter. Okay, now that's finished now. What we need to do is select our contours. There'll be quite a few of them. Here, inside here as well, and that's all. You set your depth, so I'm going to be using 6mm Perspex acrylic, so here's going to be my finished cam.